All right, Patriots, let's go ahead and get started on our semester exam review. Now, just like before on the last test, I'm going to be recording this a page at a time. So we're going to do numbers 1 through 22 here on this video, and then we will cut it and do one video per page. Also, go ahead and look below in the descriptions and also the pinned comment, and I will have a timestamp for when every single problem starts. That way you can skip around as needed. Now, this first section is a vocabulary section. Remember, this was taken from a previous exam that originally had multiple choice, and just to make you guys work a little bit harder, we took the multiple choice part off and didn't change the directions. So on the actual test, you'll be writing a letter, multiple choice, that corresponds with the answer. On these, we're just going to be selecting or writing down what the vocabulary word is that matches this definition. So let's go ahead and go through. Number 1, array that contains a vertex and divides an angle into two congruent angles. So I've got an angle here, and we're going to have an array that contains the angle vertex, and then it cuts that into two equal parts. That is going to be an angle bisector. Because remember, bisect means to cut in half, and this is an angle bisector because it's cutting an angle in half. So it's an angle bisector. Number 2, 3 non-collinear points determine a, well, if we have 3 collinear points, that would be all in the same line. However, if I have 3 non-collinear points, all 3 of those points must lie on the same plane. So the answer there is plane. Number 3, 2 angles that have a sum of 90 degrees. That's going to be like we have a right angle that is cut in two. Those are complementary angles. Now keep in mind, they don't necessarily have to be adjacent. They could be like this one is 30 degrees and this one is 60 degrees. Together they make 90. That is still going to be complementary. 2 adjacent angles that form a line. Now adjacent here meaning that they share a vertex and a side. So we've got 2 lines or 2 angles that together form a straight line. Yes, they are supplementary because they add to 180 degrees, but the fact that they're adjacent and form a line makes it more special. This is a linear pair. Now, angles formed by intersecting lines, they share a common vertex but not a common side. So we've got intersecting lines that share, we're looking for 2 angles that share a vertex. Well, all 4 of these share a vertex but not a common side. That would be, let's say we're going to take this angle. Well, this one shares a side there. This one shares a side there. This one, however, does not share a side. Now remember, these 2 are congruent to each other and they are called vertical angles. That's our Unit 1 vocabulary word that we had to go over and over again because it became so important. All right, number 6, an angle whose measure is less than 90 degrees. Well, that one is one of our vocabulary words coming in from middle school. That is an acute angle. 2 or more points that lie on a line. We've actually used that, well, a variation on the word up here. If they are on the same line, they are collinear, co meaning together, and linear meaning on the line. So they're together on a line. So that one goes for number 7. Number 8, 2 angles that have the same measure. Well, if they have the same measure, we call that congruent. And since it is an angle, they are congruent angles. Now, 2 lines that lie on the same plane and never meet. Well, 2 lines that lie on the same plane. Let's just use our paper here as our plane. I mean, if this line and this line come in together, they meet there, that's not what we're talking about. We have to have 2 lines that truly run without touching, and the only way that's going to happen is if the 2 are parallel to each other. So this will be parallel lines. Number 10. points that lie on the same plane. Well, this one's going to be very similar to that one that say two or more points that lie on the same line. If they're on the same plane, they are together, co, and then on the plane would be planar. Coplanar. Now, a point on a line segment that is equidistant from both endpoints. So we've got a line segment with our two endpoints. And I'm going to find a point that is equidistant, meaning that the distance from this endpoint to that one is the exact same as the distance from this one to that one. And if those two are the same, then this one must be exactly in the middle, and we call that a midpoint. Number 12, lines that intersect at a 90, or lines that intersect at 90-degree angles. Well, we've got our line here. This one comes in and intersects at 90 degrees. The special word for that is perpendicular lines. Number 13, a part of a line with one endpoint and extends infinitely in one direction. Okay, so if we've got one endpoint and it goes on and on forever in one direction, that one is a ray. A line array or a line segment that passes through the midpoint of a line segment. So let's go over here and take this midpoint we had earlier. If I have a line, a ray, a segment, anything that goes through that midpoint, well, this thing, this line ray segment, is still cutting this line segment in half, and so we're going to call that a segment bisector. Now, an angle that measures 90 degrees, well, if it's exactly 90 degrees, that one is a right angle. Number 16, the intersection of two planes is a, well, I mean, if we've got one plane and then another plane that comes up out of it, these two planes, they intersect right here, and that's going to happen where all the points, the intersection is all the points of the two share in common, which is going to be this line right here. So it is a line. Now, number 17. When segments have the same measure, they are said to be, well, if they have the same measure, we're going to call them congruent. Remember, congruent means same size, same shape, and the purpose, or in the situation of just a line segment, congruent means that they have the same distance. That goes along with the idea of having the same size. Now, number 18, find the distance between points A and B to the nearest hundredth. Now remember that hundredth means that it is two decimal places. The formula we're going to use here, D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And all that is underneath the square root symbol. Now, let's go ahead and plug these in. This is going to be x1, y1, x2, y2. Let's go ahead and plug in. Here's my square root, squared, squared. x2 is 4, minus x1, which gives me minus -3, converts that -3 to a positive, minus, and then we've got y2 is -2 minus y1 is 5. Now let's simplify that. 4 plus 3 is 7 squared. There should be a plus up there, I'm sorry. Plus 7 squared is going to give me the square root of 49 plus 49. Which is then going to give me the square root of 98. And then, let me grab a calculator. Sorry about that. square root of 98 comes out to 9.899, which will round to 9.90. Number 19, find EF if E is the midpoint of DF. Now EF, remember, is the distance from E to F. So let's go ahead and draw this. D, E, F. If DE is 15 minus 3x, and EF is x minus 1. Now, since E is the midpoint, that means that these two pieces are equal to each other. So, that's an arrow. So, this is going to equal that. 15 minus 3x equals x minus 1. Let's move add 3x to both sides gives me 4x. Add 1 to both sides, you get 16. Divide by 4 gives me that x equals 4. And it wants to know the distance from E to F, which is this. So, well, 4 minus 1 is equal to 3. Number 20, find the coordinates of the midpoint of AS. Now, remember the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 all divided by 2. So again, x1, y1, x2, y2. x1 is negative 4 plus x2 is 5 all over 2, comma, y1 is 7 plus y2 is 3 all over 2. And then we're going to add those up. Negative 4 plus 5 is 1, divided by 2 is 0.5, and 7 plus 3 is 10, divided by 2 is 5. So my midpoint is at 0.55. Very common mistake on this type of problem is students want to try and combine the x's and y's. That comma is there to separate them. They are two separate ideas. This is your x coordinate, this is your y coordinate, and the comma means you do not combine them at all. All right, 21 and 22. What is another name for angle 2, which is this angle here? Well, we can't name it angle y because there are multiple angles that have the vertex y. You would have to use a 3-letter name, so we're going to use angle WYX. Or you could have also said angle XYW. As long as the vertex is in the middle, it doesn't matter. Also, if there's multiple points on here, you could have chosen any point that was on each side. Now, number 22, name the angle that's a linear pair to angle 3. Well, angle 3 is here. So there's actually two that make a linear pair. Technically, we could say off of this line 3 and this angle. However, we don't have any nice way of naming this angle because y is the vertex and we don't have any points out here to name by. However, we could also look this direction. These two are a linear pair, and this means that we have angle 5. So technically, yes, this angle down here works, but we don't have a nice way of naming it. So we're going to go ahead and cut the video and then pick up again on the next one for the second page.